It's Sunday, April the 26th. April the 27th begins the last week of lecture. We've got 3 more chapters to cover. The previous video was about chapter 16, but we're going to be doing 17 in this short video. This video is not going to be too long, but I'm going to have 4 videos up for this this week. And the first one I already put up, which was video number 15. This one's going to be called video number 16, and then we're going to have a video 17 and 18. So we're going to have 4 videos up for this week, and we're covering the Cenozoic era. The reason why I'm going through this particular chapter 17, I'm going to go through it pretty fast, is because most people are more interested in life during the Cenozoic era and human and primate evolution. Therefore, I'm going to go through this one real fast. This will be a short video. Chapter 17 is about the Quaternary period. The Quaternary period. Now, what is that about? Well, that's the period we're now living in. There's 2 periods in the Cenozoic era. The Quaternary period, 2.5 million years ago till now, and the Tertiary period, 65 million years ago to 2.5 million years ago. The Quaternary period, don't forget, it's the last period of Earth history, and Quaternary period is broken down into 2 epochs. The Pleistocene epoch, from 2.5 million years ago to 11,700 years ago. And then the epoch we're now living in is called the Holocene epoch. Why do we divide Earth history in this way? Well, it's simple. 2.5 million years ago is when the Ice Age began. 11,700 years ago is when the Ice Age ended. So what epoch are we now living in? The Holocene. What period are we living in? The Quaternary. What era are we living in? The Cenozoic era. The Pleistocene epoch, otherwise known as the Ice Age, began 2.5 million years ago and ended 11,700 years ago. Much of our planet was covered by glacial ice during the Pleistocene epoch. Here you can see rivers of ice in Alaska, in Canada, northern Canada, and at the moment, only 10% of the Earth's land surface is covered by ice. However, during the Pleistocene, during the Ice Age, up to 30% of the Earth was covered by ice. So the planet was much colder during the Pleistocene epoch. Here you can see the Antarctic ice cap. The continent of Antarctica, very sparsely populated, mostly by scientists. I mean, entirely by scientists, actually. There's no native population there. Is almost completely covered by ice. We are going through a period of global warming. And this global warming, in part, is a natural cycle which began 11,700 years ago. Another way of saying it is, over the last 11,700 years, the Earth has been warming up, and that's a natural cycle. But part of it is due to human activity. And specifically, the more carbon dioxide there is in the atmosphere, the warmer Earth gets. the more methane there is in the atmosphere, the warmer the Earth gets. Carbon dioxide and methane are greenhouse gases. As sunlight, let me show you how this greenhouse effect works. It'd be easier to show you the picture. Here's a nice picture showing you how it works. Our sun releases radiation. It's short wavelength radiation, which can penetrate through our atmosphere, represented by this light blue. In other words, our atmosphere cannot block out short wavelength radiation from the sun, which penetrates straight through the atmosphere, strikes our Earth. And when that energy hits the Earth, it warms up the Earth so that the Earth sends back, here's a better picture, sends back some of this energy as long wavelength radiation. That's called infrared radiation, or heat by most people. And the greenhouse gases of carbon dioxide and methane send much of this heat or infrared radiation back to the Earth. So bottom line is, the more carbon dioxide and methane there are in the atmosphere, the warmer the Earth gets. And since the Industrial Revolution of the 1860s and 70s, we've burned trillions of tons of coal, oil, and natural gas, increasing the amount of CO2 in the atmosphere. Plus, we've cut down trees, millions of acres of trees. Trees remove CO2 from the atmosphere. And the way trees remove CO2 from the atmosphere is through photosynthesis. They take out carbon dioxide, they use water, they take in water through their roots, and they make glucose. Because plants are producers, they make their own food, and they release oxygen. That's what photosynthesis is. So bottom line is, the more trees and plants we have on our planet, the more we can fight this global warming problem. The less fossil fuels we burn, the more we can fight this global warming problem. But it's not so simple. If we were to move entirely to green energy, we would have an economic collapse around the world. Why? Because fossil fuels are the cheapest available energy source we have. And so there's going to be a transition period where we're going to move to green energy as fast as we can, and we should do it so that we can master this technology first, keep the jobs in the United States. But at the same time, we're not going to be able to do it fast. It's going to take some time. And while we're using fossil fuels, there's things we can do to slow the global warming. We can make our homes more energy efficient by using insulation. And we can use solar energy whenever possible. Parts of our country where we have high wind speeds, we can use wind energy. We can make our vehicles more fuel efficient. And the oil companies are working on ways of making fuels that release less CO2. During the Cenozoic era, volcanism continued to occur during the Quaternary period. You're going to see the Cascade Mountains in the Pacific Northwest. That's Cenozoic in age. Look how during the Pleistocene, look at that ice. That ice made it all the way down here, not to Tennessee, but to Iowa. And so much of North America was covered by ice during the Pleistocene. The planet, even though we were down here, we're not covered by ice here in Tennessee. It was a lot colder here still during the Pleistocene. Much of Europe was covered. Almost all of Germany, going all the way down to Spain. Here you can see ice winding its way up here on the east coast of South America. So during the Pleistocene, the Earth was much colder. That's why we call it the Ice Age. This is what a glacier looks like. If you took physical geology, you probably remember this diagram. And we got these glaciers called valley glaciers. Some Brits call it alpine glaciers. Rivers of ice that wind their way through the mountains, carving out the rock, eroding the rock, and depositing sediment in front of the glacier. These glacial deposits, such as glacial till, we talked about that earlier on in the semester, look like this. These are poorly sorted. They're deposited by ice. When you go to Canada, you see this everywhere. When you go to upstate New York or New England, Vermont, New Hampshire, Maine, Connecticut, Massachusetts, you see lots of this unsorted till deposited by glaciers. That's how we know that the glaciers covered up the New England area and the upper Midwest. We know that because of the sedimentary deposits that were left behind. So global warming is a concern because as the Earth warms up, it's causing a lot of problems. Sea level is rising. We're experiencing a transgression. Major cities are going to be flooded if we don't slow down this global warming. Coastal cities. We're going to get more hurricanes because the warmer the ocean is, the more hurricanes we get. We're going to get droughts because as the Earth heats up, the water is going to evaporate. Tropical diseases are going to move from the equator north. Therefore, we have to do something to stop this global warming. And one way we can do it, well, there's several ways we can do it. We can move to green energy as fast as possible. We can make our houses and cars more fuel efficient so that you use less energy. We can, as long as we're using hydrocarbons, oil, and natural gas, and coal, we can find ways to use those sources of energy and release less CO2, which is what the oil companies and coal companies are working on. We could plant more trees. I think we should do that. The Amazon forest, the largest forest left on the planet, we need to protect it and not have it all cut down because it removes a lot of carbon dioxide. But the big problem that nobody wants to talk about is there's only one way for us to really slow down global warming, and that is to stop using so much fossil fuels. Problem is, there's only one cheap alternative to fossil fuels: nuclear energy. Nuclear energy is the only way that we're really at the moment going to slow down this global warming. And people are against using nuclear energy because they're worried about meltdowns of nuclear reactors and the nuclear waste problem. They think about Chernobyl. They think about Fukushima, 3 Mile Island, when reactors have failed and the environmental catastrophes they created. They think about all the nuclear waste that presents hazards to our air and water supply. But it's not so simple. Look at countries like France. They get 70% of their energy from nuclear power. Not one single person has died or got hurt. Why? Because their reactors are designed in a way so they're not going to fail. They use one design that works. And honestly, it's a shame we don't do that here, because a lot of our energy problems would be solved. It would be good for the economy. But it's a political football. Here you can see some of the effects of glaciers, the ice carving out these bowl-shaped depressions. Here you can see you get lots of these little ponds, little lakes, as the ice melts and into these bowl-shaped depressions. These are all left behind by the ice that covered much of North America and Central Europe during the Pleistocene. This is Canada. I don't know if you've been to Canada before. Tennessee has its great beauty, the Smoky Mountains. Canada has its own different kind of beauty. Here you can see these glaciers, these rivers of ice. And they deposit till here, all along the sides of the ice. We use James Hutton's principle of uniformitarianism. If we can, once the ice is retreated, we can still find till. Therefore, we know how far south the ice made it during the Pleistocene epoch. The Great Lakes, Lake Erie, Lake Huron, Lake Michigan, Lake Superior. Please don't forget, these were formed during the Pleistocene, during the Ice Age, between 2.5 million years ago and 11,700 years ago. They were carved out by the ice during the Pleistocene epoch, the Great Lakes. Some other features left behind from the Pleistocene include this whole area here off the coast of Massachusetts: Cape Cod, Martha's Vineyard, Nantucket Island. These are all glacial deposits left behind. They're made of till, glacial till, poorly sorted sediment left behind during the last ice age. There used to be a land bridge connecting Eurasia to North America. And let me show you what it looked like. Here you can see Alaska. Here's Russia. There used to be a land bridge connecting Alaska to Eurasia during the Ice Age. You could walk across those continents, and that's so during the Pleistocene, between 2.5 million years ago, 11,700 years ago, animals migrated between these two continents, including humans. Where did the American Indians come from? They came from Siberia here in Eurasia. How do we know that? Their DNA is the same as these people over here in Eurasia, in Siberia. Artifacts can be found showing that this migration of humans occurred during the Ice Age. So the American Indians came across the Bering Straits during the Ice Age. After the ice melted, this land bridge no longer exists anymore. You can see now we're separated by a body of water here. So after 11,700 years ago, the land bridge went underwater. During the Ice Age, we had many more lakes when compared to today. Why? Because when it's colder, we have less evaporation. So we have lots of lakes that, and we know that from sedimentary rocks because we know what lake deposits look like. Usually, finely laminated shales make up lakes, plus freshwater fossils are found in these areas from the Pleistocene. So we know that there were many lakes that covered western North America. We call these pluvial and proglacial lakes. These were very common during the Pleistocene in western North America. All that's left of these Ice Age lakes are some little lakes like Pyramid Lake and Strawberry Lake, but the main one is the Great Salt Lake. That's the Great Salt Lake used to be part of a much larger lake called Lake Bonneville. So most of this water has evaporated away over the last 11,700 years. But during the Ice Age, we had many more lakes. They're called pluvial lakes. Lake Bonneville was the largest pluvial lake right here. All that's left of it is the Great Salt Lake. Question is, what caused the Ice Age? There's two ideas. There's two hypotheses regarding what started the Ice Age 2.5 million years ago. First idea, so I'm going to summarize them and write them down so it'll make it easier for you to take notes and study for this test. Two ideas, two hypotheses regarding the reason for the last Ice Age. The first is the uplift of the Himalayas. And the second is Milankovitch Cycles. Milankovitch is a Slovakian last name, so it's named after a man named Milankovitch. There's two hypotheses regarding the reasons for the last Ice Age. The first is the uplift of the Himalayas, or the Himalayas. The Himalayas were uplifted when India collided with Eurasia, pushing up millions and millions of acres of limestone. Remember that rock limestone? What's it made of? What minerals are made of? It's made of calcite. When calcite reacts with water, it makes bicarbonate, and bottom line is, I'm not going to write all the chemical reactions because we don't have enough time, but I'll just tell you, the more calcite there is, the more CO2 you remove from the atmosphere. So the uplifting of the Himalayan mountains occurred after India collided with Eurasia about 5 million years ago, pushing up the Himalayas. They kept rising, exposing more and more of this limestone made of calcite to the atmosphere, removing CO2 from the atmosphere. Some people think that the Ice Age that began 2.5 million years ago was caused by the uplift of these limestones and the removal of CO2 from the atmosphere by the weathering of those limestones. Remember when we dissolved limestone or marble or calcite and we dropped acid on it? Remember that? That's what happens when it rains on limestone. It dissolves and removes CO2. Maybe that's the reason. Second possibility is the way the Earth orbits around the sun. The Earth orbits around the sun in like this, in an elliptical orbit. Kind of looks like this. Sometimes it gets closer to the sun, sometimes it's farther away. When it gets closer to the sun, the Earth should warm up. When it gets farther away, it should cool down. Also, Earth's axis, which goes through the North and the South Pole, is inclined to the orbit produced by the yearly rotation of the Earth around the sun. And this angle this is called the Earth's axis. It varies between 23.5 and 21 degrees. So sometimes the Earth leans towards the sun, and sometimes it leans away from the sun. So there's another cycle here relating to how the Earth's axis is leaning towards or away from the sun. And that occurs every 20,000 years. The Earth's orbit around the sun makes this bent circle called an ellipse. And sometimes this orbital ellipse wobbles so that the Earth is closer to the sun or farther from the sun. Without getting into all the details, because we need to get into human evolution, I'll just say that when the Earth is leaning towards the sun or is closer to the sun, the Earth is going to warm up. And when it is leaning away from the sun and the Earth is farther from the sun, the Earth is going to cool down. And this occurs in cycles, which are approximately every 20,000 years, 40,000 years, and 100,000 years. These are called Milankovitch cycles. And Milankovitch cycles can be predicted by astronomers and geologists. We know when the Earth is farther from the sun and when it's leaning away from the sun. And that's when we get global cooling. And that's what some people think caused the last ice age. Who's right? Is it because of the Earth's orientation towards the sun? Or is it because of the uplift of the limestones? Personally, I think it might have been both that has caused the cause of the last ice age. And these are cycles, orbital cycles called Milankovitch cycles. There's a spelling for you, Milankovitch cycles. Okay, I'm going to make 2 more videos. I'll talk to you next time.